takes place, this electron is going to be transferred to the chlorine, and then sodium is going to have only 2 layers. That is the innermost layer, which has 2, and then it's only just 8. And then chlorine is going to have 3 layers, of which all of them are full. So it's got 2 electrons, and then 8 electrons, and then 8 electrons in the innermost. Now, because of the loss of electron from this side, now we have more protons. Remember, initially before the reaction, there was 8 protons and 8 electrons. But after the reaction has taken place, the sodium atom now remains with, now loses 1 electron, which means it's going to have 10 electrons and 11 protons. So because there's a higher number of protons than the number of electrons, we say that that element is now positively charged, because more positive charges are in the nucleus than the number of electrons that exist, or rather the negative charges that exist in the electron layers. On the other side, chlorine will be negatively charged because it gains 1 electron, which means that the number of electrons are going to be more than the number of protons. So because negative charges, electrons are negative charges, because the negative charges are going to be more than the positive charges, we say the chlorine atom is negatively charged. Now when they, and of course, you know, any positively charged atom is called a cation, and any negatively charged atom is called an anion. So this reaction takes place to form the molecule of sodium chloride. And that's how to write this, the symbol of sodium chloride. Now let's move on and see one more or a few more examples of ionic bonds. Structure of chlorine, 287. Remember, the other time when we were discussing about sodium chloride, we say the structure of chlorine is 287. The structure of carbon, 2882. And remember, 2 electrons in the innermost, 8 electrons in the next layer, and these are the number of electrons in the subsequent layer. So that means that carbon, actually this is calcium. Yeah. So calcium has got 4 layers. 1, 2, 3, 4. And then you will see that when the reaction takes place between calcium and chlorine, the extra electrons, which are 2 in the outside, are going to be lost by the calcium atom. So they are going to be distributed. One is going to one of the chlorine atoms, and the other is going to another chlorine atoms. So eventually, you will find that calcium chloride is written down as CaCl2. That is calcium chloride. The 2 symbol that you see here is because it's 2 chlorine atoms that react with 1 carbon atom to make up calcium chloride. So this is the formation of the calcium chloride. After the reaction, after this electron has been lost and this has been lost, now we have 0 here. So it comes down to 288. And on the other side, this was 287. Now it comes down to 288 because it's gained 1 electron from here. The same thing on the other side. Gains 1 electron from this place to make it 288. The next one is magnesium oxide, I'm sorry. Magnesium oxide, magnesium atom has got 2 electrons inside, 8 in the next one, and 2 in the outside. On the other side, oxygen has got 2 electrons inside and 6 in the next one. So when reaction takes place, both of the electrons in the magnesium atom are going to be transferred to the oxygen atom. So after reaction, magnesium is going to be minus 2 electrons. That is why we write magnesium and put a plus 2 on top of it, the way this looks like. And on the other side, oxygen is going to be 2 atoms, or rather, 2 electrons less. So you find that we write O and 2 minus on top to show that it lost 2 electrons. After reaction, this is how magnesium is going to look like. This is how oxygen is going to look like. That means they have 2 electrons in the inside, in the inner layer, and 2 electrons in the outer layer. So magnesium oxide, you find that it's going to be MgO. This is going to be negatively charged, this is going to be positively charged, because because this loses electrons, this gains electrons. So that is another example of ionic bonds. Now let's look at a few characteristics, or rather features, of ionic bonds. In general, you will see that ionic bonds have a high melting point, they conduct electricity, they are easily soluble in water, and have well-defined crystals. I guess this is the reason why they are easily soluble in water, because they have well-defined crystals which can easily react and rather dissolve in water. And then most oftenly, you will find that ionic bondings form metallic objects, as compared to covalent bonding, which are oftenly non-metallic. So a few characteristics of covalent bonds: they do not conduct electricity. Most often, they don't conduct electricity. They have a low melting point, and they have low solubility. That means they do not dissolve so easily in water. And they are often not metallic, and they are highly flammable. So those are just the few characteristics of covalent bonds and ionic bonds. And that marks our discussion for ionic bonds and covalent bonds. And see you in the next lecture. Thank you.